So good afternoon everyone. Let's pick it up from where we ended. So the question said find the vertices and foci of the ellipses given by the equation. Okay, so we found the first one and this time we have this equation. Okay, looks something like this. It is 6x squared, okay, plus sorry, yeah, so plus 3y squared is equals to 54. Okay, so remember what we discussed last time. Whenever you're dealing with an ellipse, you always need to have a 1 here. Excuse me, here. Okay, so how can you have a 1? We can just divide both sides by 54. We divide both sides by what? By 54 there as well. Okay, 54. Okay, so that when this cancels out, it will become a 1. So this here will be a 1 is equals to okay, something's wrong with my pen. So 1 there, and then we'll have 3y raised to the second power over 54 plus 6x squared over 54. Then this here will be 6 into itself, that's a 1, then 6 in there, that would be a 9. Okay, so we're going to remain with x squared over 9, then plus here when we cancel out, that would be 3 into itself, 1, 3 in there, that is 18. Then this would be y squared over what? 18 should be equal to 1. So now let's remember, okay, what are we've been taught to find the vertices, the foci, and plot it. We need to find everything. Now here's the thing, we need to compare this to the standard equation. The standard equation of an ellipse is x squared over a squared if this is big, sorry, if a is big, okay, plus y squared over b squared. It can be this, or it can be x squared over b squared plus y squared over a squared. It should be equal to 1, of course. The same goes for this. Now when we look at this, okay, this would be the case if the ellipse is oriented like how? Like so. Because in the x-axis it is smaller than in the y. So in the y, because this line is the major axis, because it's bigger, it has a. Then because it b is smaller in the x-axis, it is sorry, because in the x-axis, that's the minor axis, then for that reason we have our b here. Okay, so for this one, however, the orientation of the graph is like this. Why? Because the major axis is in the x-axis, so that is why we have an a under x, okay, and then a b under y. So that's just the revision. So in this case, so we had a 9 there and an 18 there. Okay, we need to compare to the standard equation, so we need to write this down in a way that will give us a squared at the top, not changing anything, not saying adding both sides by squared, because if we do, this won't be a 9 anymore and this won't be an 18 anymore. If we just say 9 squared and 18 squared, we need to maintain everything as it is. Okay, so what is it that we can do? Remember that time we had 25. Okay, we had to simplify it to 5 squared because this is the same as this. All that we want is to simplify it. Okay, so what is it that we can do? This here at the bottom is 9, so this would be x squared over what? 3 squared. We are done with the first. Okay, So how do we find this 3? We just got the square root of 9. Then, we had to square it. First, we find the square root of 9, which is 3. Then we have to square it. In a similar way, we need to find the square root of 18. Having found it, we need to square it. So the square root of 18 is 3 times 3 times the root of what? The root of 2. That right there is our 18 there. Okay, so this would be plus, let me just zoom in a little bit, plus y squared over what? The root of 18, then squaring it, which is 3 times the root of 2. So if you're following the lecture slide that I'm using, you'll notice that what I've written here is pretty much not the same thing. It is somewhat different somewhere. How is it different? You just see it for yourself. What they were solving. The question, of course, says it's a 6. Okay, there's a 6x something. However, with a solution, okay, they started with a 3 here. There's a 6 here in what we're solving. Then in the question, in the slide that I'm using, for those who I shared the slide with, they used a 3 in the solution, though this is a question, so that's just an error. Okay, so when we look at the 2, which one's bigger? So let's say this squared, okay, the whole thing. So when we look at this, which one's bigger? Is it the 3 or this? So 3 times the root of 2 is merely 4.2 something. Okay, it's quite long, but anyway, it's 4. Okay, when we round it off, then this here is 3. For that reason, this here is our a. Okay, and because the a is underneath the y, then our graph will look like this. So it's underneath the y, so meaning the major axis will be in the y and the minor axis will be in the x. So this is the major axis, minor axis. So this here is a 3, as we may see, so that is our b. Okay, so when we move 3 units to the right, that is where that 3 is, and 3 units to the left, that is where that is. So the coordinates, the vertices for the minor axis will be for x 0, negative 3, 0. That's x, y, and positive 3, 0. Then as for the major axis regarding this vertex and this vertex, it is going to be the root of 3 times 2. Okay, so starting from here, it is 1, 2, 3, and so on. So it just has to be the root of 3 times the root of 2. 3 times the root of 2. The same goes for this. It will be 3 times the root of 2. So the coordinates, or rather the vertices for this, will be x 0 in the x-axis, y, which is 3 times the root of 2. The same goes for the top. So that would be, for x, that would be 0. For y, it will be 3 times the root of what? The root of 2. We close. So there we have it. Okay, now here's the thing. We need to find our c, okay, where the foci is. So in this case, because this is the longest from here to here, this here is our a. From here to here, this here is our what? Our b. Now our c is just where the foci is located, starting from the origin to wherever that is. Okay, so that is our c. And how can we find the c? Using the same formula. A squared is equals to what? B squared. Let me just write that down nicely. It is going to be a squared is equals to what? B squared plus what? Plus c squared. Then we solve for c. So this would be c squared is equals to what? B squared minus a squared. Then we take the square root of the c. We cancel that out. So this would be c is equals to this. Okay. So what is our b? What is our b? B, again, is in the minor axis. It can change depending on the orientation of the ellipse. can be like this, or it can be like this. So our B in this case is in the Y. Then our B in this case is in the X. So looking at our diagram, where is our B located? As we may see, it's in the X. That's 3 to the right. So, sorry, the root of 3. Yeah, so it's just 3. Yeah, so that is 3 squared. We do this minus, what is our A? Okay, A, because it's in the major axis, is the thing starting from the origin up, all the way up. We get the positive value, not the negative down there. Okay, this is our A because it's bigger. So, but again, we can't have a negative in the square root. So there has to be an error here. We can't have a negative in the square root. Yeah, so I've seen the mistake I've made. Yeah. So that would be A squared is equals to B squared plus C squared. Then let's just solve for C, which of course is a foci. Just as we said with a parabola, it is located at some point what? Point P. With an ellipse, however, it is located at some point what? Point C. C, in this case, this here is our B, then this would be our A, because of course it's the longest distance. This is the shortest distance. Then the C is from the origin up until not the vertex, but where the foci is. So that is our C. Okay. So let's solve for C. We're going to have C squared is equals to what? A squared minus B squared. Then we take the square root of both sides. We cancel that out. We cancel that out. We'll have C is equals to what is our A? Again, A is the longest distance. A is in the major axis, and you get the positive value. So starting from the origin all the way up, our A will be this 3 times root of 2. So this has a negative at the bottom there. Then the one at the top has a positive. A is this. So we'll take that, which is 3 times the root of 2. Then we square it minus B. What is B? B is in the minor axis, which is from the origin all the way up to the vertex to the right. So that would be 3 squared. Then we take the square root there. So what we're going to have here when we punch into our calculator is our foci. Okay. So whatever value you shall find here, as long as you just rightly punch it in, that is where the foci is located. It can be in decimals. Yeah, it can be in decimals. Okay, when you do so, you locate it here. I didn't find interest to start punching it in because I don't have my calculator with me as I speak. You move down, whatever answer you shall find, obviously to be a positive. So you move up, whatever it is that number is. Maybe let's say 1.8. Okay, then this is 1.8. Then we also move downwards by what? Negative 1.8. Okay, that is what we have. So by that we can conclude, okay, we found our vertices, which is this and this. That's for the minor vertices, which is positive 3, 0 and negative 3, what? 0. Then for the major vertices, we found them to be the root of 3 times 2, 3 times root of 2, and what? So 0, 3 times root of 2. Yeah, it is x, y. So that's 0, 3 times root of 2. So this here is this here. Then what else? 0, negative 3 times the root of 2. We close. What else? Yeah, so we found the vertices, minor vertices, major vertices. Our foci is this here, which was found using this formula. What else? And we've graphed it. Yeah, so we found pretty much everything. So let's move on. Okay, so now what if they tell you, so this other example, the vertices of an ellipse this positive plus minus 4 comma 0 and the foci are 2 comma 0. Find its equation. We need to write down its equation. And we're being told it's an ellipse. Okay, so it needs to have the form of x squared plus y squared. And then we don't know what this is. We don't know what this is. We don't know which one's A. We don't know which one is B. Should be equal to 1. Okay, but all that we've been told is that, let me just zoom in a little bit. All that we've been told is that the vertices, okay, are plus minus 4 comma 0. We close. These are the vertices, okay, and the foci, it is plus minus what, 2 comma 0. The reason why they're saying plus or minus is because it can be either to the right or to the left of the origin. Those are the vertices. Now these are the vertices, so let's draw this xy plane. So it looks like this, yeah, and we're being told it's an ellipse, so we don't know whether it orients like this or its orientation is what, like this. But one thing we need to look at is this. Look at this here. That's in the x, because always whenever you have coordinates, this is x comma y, this here is x comma y. So in the x-axis we have plus 4 and minus 4. So plus 4 and minus 4. This is what the foci. These are vertices, the very end points. So if this is your ellipse, these are the vertices here. So looking at what we have, this is 4, this is negative 4 comma 0, of course. Okay, then the foci is located at negative 2. So when we move, it is going to be at negative 2. So starting from the origin all the way up to wherever 2 will be here, if we just draw it nicely by saying 1, 2, and so on. So our 2 is somewhere here. So that is where the foci is. That's negative 2. Then this here is what? Positive 2. So negative 2, positive 2. Okay. Now, thing is, we don't know what our B is. Okay. We would have drawn it like so. Would have drawn it like so. We would have drawn it like so. We don't know how wide it is, because the B would be the guidance. The B, since it's smaller, because as we may see, this here is the major axis. Okay. Actually, we don't know if B is a major axis or minor axis. We don't know. Maybe this conic section can actually look like how? Like so. Who knows? Okay. Then the 4 is here. Then the 4 is here. We don't know what this ellipse would look like. So we need to find the B first. And when we find it, we'll be able to determine whether the B is our minor axis or our major axis, or if the A is our the A is always the major axis, but finding the B would help us figure out if the major axis is in the X or in the Y. So how can we find out B? Using the same equation. A squared is equal to what? B squared plus C squared. We know what our C is. Our C is the foci or focus. Okay. B is what we're looking for. A is this. Okay. So now let's see. What is our A? That's 4 squared is equals to B squared, which is what we don't know, plus C, which is 2 squared. So this here will be a 16. It should be equal to B squared should be equal to what is 2 times 2? Yeah, sorry, this is plus 2 squared. That is a 4. Okay, so this would be B squared is equals to 16 minus 4. So this would be B squared is equals to 12. So the root of 2 there, we take the root of 2. So we take the square root there, square root, we cancel out. So our B is the square of what? Of 12. That is what B is. Okay. So, yeah. What's the square root of 12? It's 3.46. Now, because 3 is smaller than this right here, 4, then obviously our minor axis is at the top there. Okay. By that I mean to say, because our graph looks like this. Okay. And A, we just draw that nicely. A is from here to here. So from the origin up to here, that's 4. Then this here is negative 4. then from the origin to the to C, which is the focus, is 2. Then this here is -2, and we figured out that our B is actually the root of 12, which is 3 point something. So it would be somewhere here. Okay, then just put it as the root of 12. The same goes there, the root of 12. So it would look, our ellipse would look something like this. So now let us just locate these vertices. So the root of 12 there. Okay. Yeah. So now let us, what does the question say? Find the equation in standard form. Okay. Yeah. So that is just how you graph it. We haven't even found the equation. So to find the equation, this here is x squared should be what? X squared over, let me not even say over a. No. Let's say x squared plus y squared is equals to 1. Then over and over here. What should we put here and there? Which one is our a? Which one is our b? As we may see, starting from the origin to here, that is 4. Okay, then starting from the origin all the way up, it is a root of 12, which is 3 point something. So 4 is greater than 3, even 0.2. Okay, 3.2 something. 4 is greater. Okay, and because 4, which is great, is in the x-axis, then our 4 will be here, 4 squared. Okay, what about y? Here, what should we put? That is b. Okay, we need to put the root of 12 squared. Then we have our answer, but this just doesn't look neat. Let's simplify it. So this would be x squared over what? 16. It's okay for you to write it down like this. Plus y squared over what? This will go, that will go. Over 12 should be equal to 1. This is our equation. Let's do another example. So, says find the equation in standard form of an ellipse whose foci is 3, 0, okay, and -3, 0, and major axis of length 10. Excuse me. So this is what we have. Okay, this let me not even draw it in a way that would assume that the major axis is in the x. So yeah, we don't know whether the major axis is in the x or y, but the foci is what would help excuse me, help us. So assuming you've got the foci here and here, then you should know saying by default it looks something like this. But if you have the foci or the focus here and another one there, they should know saying it looks something like this. Okay, the same way you should know saying that, okay, whenever you have a parabola, okay, this here is the origin, then it opens like this, and then if it is located somewhere at the top, okay, then it opens like this. If it's located here, then it opens like this. If it's located here, then it opens like that. So what have they given us? Find the equation in standard form of an ellipse of foci 3, 0. So it is 3, 0, okay, and -3, 0. Out of just this information, and then we're told saying that the length of the major axis is 10. Out of this, you need to find the equation. So as we may see, this is what is this? This is in the x. Okay, this is x, y. Okay, so when we move towards the right, we move 3 units. Okay, 3, 0, which is the first one, and then -3, 0, which is the second one. These are the coordinates for this and this. So yeah, +3, 0, -3, 0. We don't know, excuse me. Oh, so far this is what we've known about it. Okay, and because the foci, I don't know if I say focuses, but anyway, these points, this one and this one, would tell us that we are now in the major axis, just like I was drawing there. You know, if you have 2 here and here, then the line goes like this. Then this same line is the major axis. So we've been taught saying that the length of the major axis is what? What is the length? 10. So meaning we've got 5 this side and 5 on the other side. Okay, so this was 3 and 3. So meaning this would be 3, then 4, 5. Okay, so that would be a 5 to the right and -5 to the left. So this will be negative there, then -5 there. Okay, Then we don't know again how wide this is. It can be like so, it can be like so, it can even be like so, but it can't be like this. Why not? Because the the foci is here and another one here. Okay, that's where they are. So they need to follow the major axis is always the one that has the foci in its axis. So we have our C, we have our A. Why are we calling this A? Because we know, not that we know what B is, and then because we know what B is, and B is smaller than A, then this 5 is now our A. No, we didn't make that assumption. The reason why we're calling this 5 an A, the reason why we're calling it an A is because, like I've said one more time, let me just emphasize this point. Because this is the origin, okay? Then if the foci was here and here, okay, then this is the major axis, meaning from the origin up until this point, that is your A, because the foci are in this line. And if it were to be located here and here, meaning the major axis would be in here. So that is why we're calling it an A. Now let us find B. How else can we find B? It is the same equation, okay? A squared is equals to B squared plus what? Plus C squared. What is our A? We know what our A is. A is 5. So that would be 5 squared is equals to what is our B? We don't know what B is. That's what we're looking for. What is our C? C is 3. Okay, we always get the positives. 3 squared. So this would be a 25. Should be equal to B squared plus what is 3 squared? That is a 9. Then when we solve for B, this would be B squared is equals to 25. 9 goes to the other side, it becomes a negative. 25 minus 9, 16. So that would be B squared is equals to 16. We do that, we cancel out. We have the root of 16, which is what? 4. Okay? And it's even making sense if you think about it. Okay, even if you don't think about it, it still makes sense. The major axis is always greater than the minor axis. It can be in here. For now, let's take it as this. So if 5 is the major axis here, starting from the origin going up and down, that's positive 5 and negative 5. Meaning the minor axis has to be less than 5. So we already established that 5, where is our 5? Here, is our A. Because this and this are in the x-axis. So meaning our B, which is smaller than A, has to be smaller than 5, which is what? 4. So the equation would look something like this. This would be x squared plus y squared over should be equal to 1. What is our A? Our A is 5. And where is 5? 5 is in the x-axis. The reason why we're calling it A again is because it's greater than 4. So it is going to be 5 squared plus, what is our B? It is 16. Now, sorry, it is 4 squared. Now the reason why I just want to make this clear and emphasize the reason why we are not getting the root of 4 and the root of 5, sorry, the root of 4 and the root of 5 here. The reason why we're not doing this is whenever you draw your ellipse or conic section, if this here is a 5 and then this here is a 4, okay, then it means we've taken A and B, but in the equation we have to square them. You see, that is what we've gotten. But if we've been told or given the equation already that has 16, we didn't plot until 16 here, or even if we do, 16 in this case will be our A, as long as this is where the vertex is. And then when we want to substitute it in the equation, we have to say 16 what? 16 squared. But whenever you're given the equation, then it doesn't have a square on top, then you should know saying that for you to, that is not your A. Say you have 16, this is x, and then plus 25, okay? Y squared, then should be equal to 1, of course. This is what you've been given. There's no squared there, okay? Yes, so you have to say x over 4 squared plus y over what? 25. sorry, over 5 squared. Then this here is your A, and then this here is your B. Why are we calling this A? It's because it's bigger than the other one, okay? And because the one which is bigger is under the Y, then the equation will look like this, where the major axis will be in the Y. So this would be 5 from there, negative 5, then positive 4, negative 4. So we're done with this question. We found our equation. Now let us look at what is known as the eccentricity. What exactly is the okay, I think it's up to you to now pronounce this. But yeah, what is this exactly? You know, a circle looks something like this. An ellipse looks something like this or this, okay? Somewhat oval or a bit flattened. Now, this is your circle. Now let's assume our ellipse is almost close to a circle. This is an ellipse. This is a circle, okay? Then this is also an ellipse. So the eccentricity is a ratio of its the axis, okay? It's the ratio of its what do you call the focus to the major axis. It tells us how flat or wide this ellipse is. So this here is eccentricity is given by what? C over A. That's all that it is, okay? So let's assume, let me just give an example. So if your A, which is of course your major axis, is 5, okay, we've gotten 5 too much, let's get 8, okay? Then this is just a 2. Then from here to here, okay, that is where our C is. And our C in this case turns out to be a 5. Okay, we're back at 5. A 2. Okay, and then maybe let's take that to be a 4. Then with the other one, its eccentricity is let's see, let's take maybe 8 itself, okay? Then the focus is located somewhere close. No, it has to be very far. If it looks more like a circle, then it's not too close. If your parabola looks like this, then the focus is here. It means it's close to the vertex. That's why it looks like that. But if it looks widened like so, then it is not so close here. No, it is somewhere far away. So this circle looks a bit far. So let's take our focus or our C to be 1. Excuse me. So in this case, the eccentricity in this case would be E is equals to what? C over A, where our C is what? 2 and our A is 8. So this C into itself 1. There it is a 4. So 1 over 4. This is its eccentricity of this. Then in this case, our eccentricity for this one will be E is equals to C over A. What is our C? Our C is 1. Our A is 8. So that is our eccentricity for this. So let's look at an example. So we're being told, okay, saying find the equation of an ellipse. No. Let's do one about eccentricity. Yeah. So find the eccentricity of the ellipse given by the equation 8 squared plus 9y squared is equals to 18. Excuse me. So this would be x squared. So 8x squared plus 9y squared is equals to what? 18. Then we're being told to find the eccentricity. So we're going to say divided by 18, divided by 18, divided by 18. Why are we doing this? You need to have a 1. So 18 divided by itself, what we're going to have here is a 1. It should be equal to 9 into 18. Okay, that there will be a 2. So this will be y squared over what? Over 2. Then this here, let's simplify it because 8 doesn't go into 18. So this would be 8 into itself. No. 2 into 8. That is a 4. 2 into 18, that would be 9. Okay. So in order for us to get rid of that 4 at the top, we need to divide the top and the bottom by what? By 4. So we'll say, or multiply it by 1 over 4. And this we'll say by 1 over 4. So this 4 goes, that 4 goes. Then this 9 will multiply with a 1 to be 9 over 4. So it is going to be plus x squared over what? 9 over 4. So as you may see, this is what we have as our equations. So because let's see, this is greater than this, okay? So yeah, x, the major axis lies in the x-axis and the minor axis in the y. Now this is not our a and this is not our b. Our a is found when we take the square root of 2 and then we square it. A similar way, our a will be not this, okay, but what I mean to say is this: assuming there was a 25 here, this is not our a. Our a is 5. Our a is 5. Okay, this is the same as this, yes, but our a is 5. So let's find our a and our b. Okay, so we first take the square root, just like we had 25. Let's take the square root of 25. We have a 5. Okay, so that is the square root of 25, and then we square it, so that would be 5 squared. Then this is our a. So let us do the same thing here. It is going to be, what is the square root of 9 over 4? It is going to be 9 over 4 its square root, and then we what? Square it. This is the same as this. So, because of course this just cancels out. So, what's the square root of 9? 3. What's the square root of 4? It is 2. So, yeah, what's the square root of 9? It is 3. What's the square root of 4? It is 2. So that would be a square there. Okay, so this is now our a, not this. Then what is our b? B is just the square root of 2 squared. So meaning this, the square root of 2, the root of 2, is our b. So the eccentricity, as discussed, is c over a. Do we know what our c is? Let's see. No, we don't. So we need to find our c, and then we divide it by our excuse me, by our a, which is 3 over 2. Okay, how else can the c be found? It's just a squared is equals to b squared plus c squared. So c squared is equals to a squared minus b squared, and then this would be c squared is equals to, what is the root of, so sorry, yeah, we introduce a square root, of course, so this goes, that goes. Okay, so that is why we're going to have c is equals to, what is our a? Our a is 3 over 2, so we'll say 3 over 2 squared squared 3 over 2 squared minus, what is our b? In this case, our b is just the root of 2. Okay, the root of 2, we'll say squared. We do that. So c is going to be, when we simplify, okay, let's see, this will go, that will go, then this will be 3 squared, that is a 9, over 2 squared, that is a 4, then we do so minus 2. Okay, we can just simplify this by saying over 1, we look for the common denominator, we say it is 4 into itself 1 times 9, it is 9, minus 1 into 4 4 times 2, it is a 2. Okay, and then we say c is equals to, what is 9 minus 2? 7. So the root of 7 over 4, this is our what? Our c. So eccentricity is equals to c over a. What is c? The root of 1 over 4 divided by a. What is our a? Our a is this, which we found here. Where? Here. Not this, okay, but this. No, this here, which is 3 over 2. So divided by what? By 3 over 2. So because we're multiplying, we're dividing by a fraction, e is going to be the root of 1 over 4 times 3 over what? 2. So this can be simplified. This would be e is equals to, what is the square root of 1? It is just 1. What's the square root of 4? It is 2. So this would be 3 over 2. Then e is equals to, what is 3 times 1? It is 3. Okay. What is 2 times 2? That is 4. So our eccentricity is what? 3 over 4. Yeah, so another error right there. Whenever we're switching from division to multiplication, this fraction has to flip. So it's supposed to be after flipping, okay? Eccentricity is equals to C over A. Our C in this case is what? The root of 1 over 4 divided by our A is 3 over 2. So when this will change to multiplication, this will be, let's simplify this first. So that would be what is the square root of 1? 1. What's the square root of 4? 2. Then this will switch, okay, because we've changed the sign. So this will be 2 over 3. So this will be E is equals to what is 2 times 1? That is 2. What is 3 times 2? That is a 6. So 2 into itself 1, 2 into itself 1, 2 into 3. So yeah, 2 into 6, it is a 3. Okay, so our eccentricity finally is 1 over 3. So kindly subscribe and share this video to your friends, and ensure that you just practice questions and understand instead of memorizing. So that is what school is all about. So a summary of what we have done is that this is an ellipse, major axis, minor axis. Okay, the foci is here, C is this, the C is that side, eccentricity is C over A. Okay, the eccentricity tells us more of how wide it is. If your focus is somewhere close by, okay, it will look something like this. But if your focus is very far away from the vertex, it will look like this. Whenever you have 2 points, 1, 2, then you should not say your major axis is oriented like so. Then whenever your points are like this, then you should not say your major axis is oriented like so. Okay. Another thing is, what else? You may have A, you may have B, but you don't have your C. So you can just find it by A squared is equals to B squared plus C squared.